Hello, welcome. This is question number 2 for Edexcel's M1 June 2014. Okay, so we're given that there's this inclined plane, of 40 degrees to the horizontal. We've got this point where the particle P, which has a mass n kilograms, in other words, we're not told the mass. Okay, it's being rested at point A. We're told there's this other point B on the inclined plane, okay, which is 3 meters away. So therefore, obviously, doesn't take a genius, although I am a genius and I worked it out. Now that is 3 meters. Okay, so it's 3 meters from A to B, and the angle's 40 degrees. It asks us to, it also tells us that the coefficient of friction, labelled as mu, is equal to 1/2. And it asks us to work out the acceleration of P down the plane. You may be going, again, how the hell are we going to work out the acceleration of this without a mass? Because as we know, the equation goes mg sine theta minus ur, okay, r being the reaction force, is equal to ma. That all involves a mass. But let's just assume that we did know the mass. We'd work it out in the same way, because there's no other way we can work it out. And even if you only did it this way and didn't notice this bit, it's a key really to do. Okay, so just apply as you would before. Okay, so you do mg sine theta minus mu r is equal to ma. Now, obviously, what I'm going to do here is just label on all the forces. So obviously we've got the weight acting directly downwards. We're not really interested in that. It's just W equals mg. Perpendicular to the plane, okay, it's labelled as mg cos theta. And obviously, because it's not sinking, the reaction force off the plane, labelled as r, is equal to also mg cos theta. Okay, obviously, going down the plane, God's sake, I should go into it at that rate, we've got mg sine theta. Okay, and pulling up the plane, we've got mu times r, the coefficient of friction times the reaction force. Okay, so we know the reaction force is mg cos theta. We'll just sub it into this equation that we've got so far. So again, it's mg sine theta minus mu, which is 1/2 times r, r being mg cos theta, so it's minus 1/2 mg cos theta, is equal to ma. Now, both of these sides have got a common factor of m. Now you could take that out and work from there. However, as both sides have got a common factor of m, okay, we can divide both sides by m, okay? So therefore, in other words, we cancel out the m on both sides. So as I said, you could actually do this if this makes more sense. Take m out as your common factor, so you've got m times g sine theta minus g cos theta. Sorry, minus 1/2 of g cos theta. Because all I've done is taken m out as a common factor. Is equal to, we can take m out as a common factor, m brackets a. Now we can divide both sides by m, in other words we can cancel out the m's. So we've got g sine theta, take 1/2 of g cos theta is equal to the acceleration. Now obviously we know the angle and you know what g is. Okay, so just a case therefore of subbing in your answer, your values. So g sine theta is obviously 9.8 times the sine of the angle, which we know is 40 degrees. So it's 9.8 times sine 40, take 1/2 of 9.8 times cos 40. Okay, that will give you your acceleration, and you should get the acceleration equal to 2.5 meters per second squared, obviously. Okay, so hopefully you get why that is. I'm actually quite impressed with that drawing, just like that, because that drawing is not actually crap. It's actually acceptable. In concept, you'd think a human has done it as opposed to an animal. Okay? Right, so very basic, and again, hopefully you spotted now. Now, if you didn't, you could have just assumed the mass of this was 3 kilograms, because it's not specified what it is. So you can just come up with an answer as long as you use that value, whatever answer for m you come up with, whatever weight, mass you want to give it, okay? you can say, you could work that out in the same way. You could just put a value for the mass. You could say, well, let's just assume the mass was 3 kilograms. Because that could actually easily be a question saying, how does the mass not affect the acceleration of an object down the slope? And you just say it cancels out on both sides. Because the common factors, you can divide it so it's not affecting the acceleration. Because you could just go with any mass, and for the plane, all it depends on is the angle and the coefficient of friction. It doesn't depend on anything else. Okay? So, as I say, they could have added another bit to that question, but they didn't. Okay? So it's just a case of cancelling out the m's. Because obviously you know everything else. Right, so that was fairly simple if you spotted it. The next bit is even more so. Because now we've taken into effect the angle, because we worked out the acceleration is 2.5 meters per second. The next question says, find the speed of p at b. Now, it's crucial that they mentioned, they'll always mention this unless they explicitly say otherwise. You always assume, okay, it's at rest initially. Okay, so it's being held at point A. In other words, it's at rest at point A. So therefore, you take the initial speed to be 0. Okay, so it's asking us to work out the speed at B. Okay, so we know that the initial speed was 0. Now obviously we wouldn't know the final speed just yet, we've got to do some calculations. So I just put as kind of question mark meters per second, or x meters per second, whatever you want to call it. Alright, but ideally I want to stay away from x and y's as long as I possibly can. For the rest of my life even. Okay, so we know the initial speed, we want in the final speed. We've just worked out the acceleration, and quite clearly that's going to help us to some degree. So acceleration is equal to 2.5 meters per second. Okay. What do we also know? Well, we also know the length A to B is 3 meters. So in other words, distance S is 3 meters. Okay. So we know all of these facts so far. But again, we want to work out the velocity. Now, in mechanics, they don't give you any super equations. However, the most common ones they use are v squared equals u squared plus 2as, and v equals u plus at. The other two, they generally don't, okay, unless it's falling. But, as I say, you should spot that there's nothing else we can come up with. We could say, well, what's the time? Well, we don't know the time. You could go, well, we could work that out from the acceleration, but then we'd have the final velocity. So they're the only things that we can work out, okay? So therefore, the equation that combines u, v, a and s, okay, now you don't need to use them all, but obviously there's no equation where we can just use v and u without t, see? Okay, so I'm just going to use the equation v squared is equal to u squared plus 2as. Again, I think for these super equations, it's just a case of doing so many questions you just remember them, okay? Now, I remember them off the top of my head because I did physics last year and just used them so many times, just come into my mind. But as I say, if it doesn't for you, then it's just a case of remembering the formula. And to be honest, this question is only worth 2 marks anyway, so it's not such a big deal if you don't get it. Okay, so v squared is equal to u squared. Well, obviously, u squared is 0, but it's still right in the 0 meters per second and bracket and square it, and then you're adding 2 times a times s. Well, we know s is 3 meters, we know the acceleration is 2.5, so it's 2 times 2.5 times 3, okay, so v squared is obviously 15. Have I done that right? So is my acceleration right? Now I've rounded this acceleration up to 2.5 meters per second. I would advise using the exact value you got for this. Okay, so go back to your acceleration equation, do it again, have it as a saved answer, do 2 times acceleration times 3, and I got 15.3. So therefore v squared is equal to the square root of 15.3, okay, which gets you 3.9 meters per second. Now if you use the rounded figure of 2.5, then you're a colossal idiot. But obviously, you would be allowed that. Okay, so I got 3.9 meters per second. You might have a slightly different value. Okay, some of you might round it up to 4 meters per second, but it doesn't really matter. Okay, as long as you get it in the ballpark of that figure. Alright, So that's the end of question 2. Quite a nice question and a very easy question on inclined planes. But then again, it is only question 2. And I might say this is a little bit harder for question 2, but as I say, it was a very, very standard question. Alright, so thanks for watching, and we'll see you in the next question.